for this topic. So there are proofs on this. Again, it's not nearly as long of a homework, though. I think there's just like 3 proofs on it. And then the entire front, or at least part of the front page of the homework, is just like review of some other stuff. Wednesday, during our 8-block day, we're just going to recap some things from the chapter. So I might put like a practice proof on there to get you guys ready for your test. Some different identification stuff, finding angles, just things to get you ready for your test. Thursday, we're going to review, and then next Monday, you will have your Chapter 5 test. The proofs on there should be pretty short, but you should expect at least a few on there. But they'll probably be like some fill-in-the-blank type stuff. So again, if you're still lost, make sure you talk to me. All right, so topic 5.4. Using congruent triangles, I would probably, have your 5-3 notes close by, have your vocab sheet close by, because this is just like one little continuation off of it. So using congruent triangles. Remember, congruent triangles have congruent corresponding parts. Those are like your matching parts. If 2 triangles are congruent, then their corresponding parts must be congruent. So if I tell you that 2 triangles are congruent, then any part of them that matches up must be congruent. Like, for example, let's say we have 2 triangles here. I'm going to call this one ABC and DEF. If I tell you that these 2 triangles are congruent, then if I pick out any set of matching sides or any set of matching angles, it must be congruent. So if I tell you triangle ABC is congruent to triangle DEF, then angle B has to be congruent to angle E, right? Then side AC has to be congruent to side DF. Does that make sense, guys? Okay, and you can do that with any set of sides, any set of angles. That is where, this is technically a theorem. We kind of turned it into a phrase. But this is where this comes in. This phrase, it is bold, it is italicized, it's in like size 16 font. Okay, it is important. It's really the main concept for this. And it is that corresponding parts of congruent triangles are congruent. In other words, the matching parts of 2 congruent triangles must be congruent to each other. So if these 2 triangles are congruent, any set of matching sides or any set of matching angles is congruent. And this gets abbreviated with CPCTC. That's just the little abbreviation of this phrase because this can be a bit of a mouthful. This is actually going to be a new reason we use in our proofs. So I want to give you a few hints for your proofs. Your proofs could look 2 different ways. You just spent that whole homework doing proofs where you're trying to prove one triangle is congruent to another triangle. Those aren't going to go away. You still need to know how to do those. So remember, if you were trying to prove that triangles are congruent, your proof should end in one of those theorems. Like, for example, side, side, side. What was another one of those theorems? Angle, side, angle. Good. What's another one? Good. So angle, side, angle. Which one did you say, Gannon? I'm sorry. Side, angle, side. Yes. Side, angle, side. What's another one? We can look at our 5-3 notes. Yeah, L said hypotenuse leg. And then what's the last one? It's another one that starts with angles. Yep, angle, angle, side. Okay, so if your proof is that two triangles are congruent. So if your proof says prove triangle ABC is congruent to triangle DEF, your proof must end in one of these 5 theorems. However, if you're trying to prove that parts are congruent, and by parts, I mean angles or sides. So if your proof says prove angle A is congruent to angle D, or prove angle segment AC is congruent to segment DF, then your proof needs to end in CPCTC. Okay. So if you take a look at this first proof here, it says prove that angle Q is congruent to T. Well, that's not saying prove the two triangles are congruent. That's saying prove that the two parts are congruent. So this means this proof must end in CPCTC. Now the question is, how do you do this? All right, well, really, it's the exact same thing we've been doing. You just then, after it, need to do one extra step. And that extra step is almost a freebie. So our first step here is we're still going to prove that our two triangles are congruent. So if you take a look, I want to prove that angle Q is congruent to angle T. But they're not marked as congruent. They're not vertical angles. I just don't have that information right now. But what I'm going to do is prove that the two triangles are congruent. And if the two triangles are congruent, then any of their matching parts are congruent. Q will be congruent to T. R will be congruent to S. QR would be congruent to ST, any of those parts. So here's what I would do when you see a problem like this. First, just like before, always fill in your freebies. So let's put in our given. P is the midpoint of segment QT and segment RS. So there is our given. Then we want to prove that angle Q is congruent to angle T. Now, I actually have more freebies than just this, though. I know that I'm trying to prove my parts are congruent. So go up above. If I'm trying to prove parts are congruent, what must my proof end in? Exactly. I have congruent parts, so I know I have to use CPCTC. I'm trying to prove that corresponding parts of congruent triangles are congruent. But to use this, I have to have congruent triangles. So I actually have another freebie. If I'm going to do this, then the step right above it, I need to be able to say that these two triangles are congruent. So right above it, I need to be able to say that, oh, I think this one I might need an extra step for. Sorry, guys, I forgot that I meant to add a line. Yeah, well, I'll just move this down a little bit. My bad. I'll just put that right underneath. So, or I'll just kind of like split this line into two. So angle Q is congruent to angle T. That's CPCTC. And right above it, I'm going to need to prove that the two triangles are congruent, because for that to work, I have to have congruent triangles. So I'm going to say that triangle QPR is congruent to triangle. And remember, if I name the one QPR, I have to match up my information. So QPR would go with TPS. Now, I don't know how I'm going to say they're congruent yet, but I just know that I need to do it, because to use CPCTC, you have to have congruent triangles. So now we're going to approach this the exact same way we did in 5.3. You're not given any freebies, so let's look at your given. P is the midpoint of QT and RS. So if we have a midpoint here, what is a midpoint going to do to either of these two segments? Who can refresh our memory? What's a midpoint going to do? Very good. It's going to split them into congruent segments. So I'm going to be able to say that these two segments are congruent and that these two segments are congruent. So I'm going to say that QP is congruent to TP, and I'm going to say that RP is congruent to SP. Again, you had a midpoint. A midpoint is going to give you congruent segments. So that is the definition of a midpoint. All right, we had a vocab word, so we needed to use it. Midpoint, use the definition of a midpoint. Now I've used up my given, so now I got to look at my picture. What is a picture like this always going to give us? Who remembers? Vertical angles. Your bow tie shape is always going to give you vertical angles. So we're going to have congruent angles in the middle there. And then again, to simplify it, I like to label them as 1 and 2. So this is angle 1 and angle 2. So I'm going to then say that angle 1 is congruent to angle 2. Does anyone remember the appropriate reason for that? It is, yep. So vertical angle theorem. Now I just got to figure out, okay, why were my two triangles congruent? Well, let's take a look at the information we were given or that we discovered. We had a set of congruent sides here with QP and TP. We had another set of congruent sides here with RP and SP. And then we had a set of congruent vertical angles in the middle. So take a look, which theorem do you think would work here? Do we think it would be side, 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 angle, side, angle, side, angle, 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 side? What? Side, angle, side. You have two sets of congruent sides and the angle in the middle. So that would be side, angle, side. And then at that point, your proof is done because you've already filled in your last step. Because if I can say that these two triangles are congruent, then I know angle Q will be congruent to angle T because they're corresponding parts of congruent triangles. So again, your process here is to prove the two triangles are congruent. Then if the two triangles are congruent, their parts are congruent by CP/CTC. So really all we're doing now is just some more examples. So let's take a look at this one. We actually saw a picture just like this in our homework before. So here we are given that segment AB is parallel to segment DC. So the top is parallel to the bottom, and angle C is congruent to angle B. So those are our freebies. Now we're trying to prove that segment AC is congruent to segment DB. So in this proof, are we trying to prove the triangles are congruent or that their parts are congruent? Parts. And if we're trying to prove parts are congruent, what do I always have to end our proof in? Good, yep, CP/CTC. Corresponding parts of congruent triangles are congruent. But in order to use this, what are we going to have to do right before? If I want to show that corresponding parts of congruent triangles are congruent, what am I going to have to show to make that happen? Exactly. I have to show that the two triangles are congruent, because if the two triangles are congruent, then their corresponding parts are congruent. Again, you can't use this unless right above you show the two triangles are congruent. So in step 4, we need to show that triangle ACD is congruent to triangle DBA. Okay, we're not sure what the reason is yet, but these are basically all freebies. Put in your given, put in your prove. If you're trying to prove parts are congruent, it's CPCTC. And in order to use CPCTC, then right above, you're going to have to show the triangles are congruent. Kind of think of it like working backwards. If I have to show parts are congruent, then first I have to show the two triangles are congruent. All right, so let's see how we can prove our two triangles are congruent. We were given our parallel lines, and we were given a set of congruent angles. So we have a freebie here with our congruent angles. So let's look at our other given. What are parallel lines going to give us? Who remembers? We just talked about it a few times in our homework that we went over. Good, yes. We are going to have alternate interior angles. We're going to look for our Z shape. So here, if it's the top and bottom, we just connect our transversal and do our Z shape here. Then look in your corners. I'm going to say that this top one is angle 1, and then this one's angle 2. And what can we say about our alternate interior angles? We can say that they're what? Congruent. Good. So I'm going to mark that these are congruent. And I'm going to say that angle 1 is congruent to angle 2 by the alternate interior angle theorem. Okay, so now I have another set of congruent angles. So I have an angle and an angle. That means I need a side. Does anyone see a place here where we could have a congruent side? Yeah, we have a shared side. We have a shared side right here. Who can tell me what the name of that shared side is? What would I call that segment? Like, what are its two endpoints? AD, exactly. So this is segment AD, so we can say that segment AD is congruent to segment AD. And who remembers what property you would use there? Good. Reflexive. Yes, L. Uh-huh. Okay. Mm-hmm. So for that one, just because two lines are parallel does not necessarily mean they're congruent. Yeah, because like you could have like these two lines, they're parallel, but they're not necessarily congruent. Do you see what I'm saying? So with that one, you want to use your shared side instead. All right, so then we have, just to figure out how we're going to say these two triangles are congruent. So take a look. We have two angles and a side. So if you have two angles and a side, it's really going to be deciding between angle, side, angle, and angle, angle, side. Which one do you guys think it would be based on what we have here? It would be angle, angle, side. Good, because the side does not connect the two angles. For it to be angle, side, angle, this side would have to be here. It'd have to connect them. Good. So this would be angle, angle, side. Good. And then we already have the bottom part filled in. If these two triangles are congruent, then we know that segment AC will have to be congruent to segment BD because those are corresponding parts of two congruent triangles. Questions on that one? Are we kind of seeing how it's the exact same thing we were doing before, just you do one extra step at the end? Sure. Uh-huh. So Gannon, I do not care what order you write it in as long as they match up. So here I did A, C, D. So that's like starting up here, you go along your short side and then along your long side to D. So you want to just kind of follow that same pattern in the other one. So if you do A, C, D, you have to do D, B, A. Let's say I had done something else. Let's say I had said C, D, A. If you do CDA, then you have to do BAD. Okay, but if that shows up on your test, I'll probably have one of them filled in and then you'll just have to fill in the other one with the corresponding information. Okay. All right. I think we just have two more. Two more? Yeah. Two more and then we're done. And then so you guys can have some, oh, well, I guess going over that homework took a while, so we don't actually have that much time. All right, so this next one, we have that segment CB bisects angle DCA and DBA. So we have an angle bisector in two places here. We're trying to prove that segment CA, so segment CA is congruent, CA is congruent to CD. So are we trying to prove triangles are congruent or parts congruent? Parts. If we're trying to prove parts are congruent, how do we need to end our proof? Exactly. So let's put in our freebies, our given. So segment CB bisects angle DCA and angle DBA. So there is my given. And then I have a few other things filled out for you. Like here, I went ahead and put in your proof. So that's CPCTC. And then in order to do CPCTC right above it, we have to show the triangle ABC is congruent to DBC. Because to use CPCTC, you must have congruent triangles. So let's see how we're going to prove those triangles are congruent. Now I gave you a hint, and that's to use the definition of an angle bisector. Again, you are given an angle bisector here, bisects, and then two angles. So can someone tell me what an angle bisector does? Good. An angle bisector is going to take an angle and it's going to cut it into two congruent angles. So we actually have a bisector happening in two places here. It's bisecting DCA. So DCA is right here. And it's bisecting DBA, which is right here. So that means either of those corners there are getting cut in half. So to make your life easier, I would rename those with 1 and 2 and 3 and 4. And if something like that shows up on your test, I'll already have them labeled with numbers. So I'm going to say 1, 2, 3, 4, like that. All right, so I'm going to say that these are congruent, and you can do this in one step or in two steps. I have enough lines for this one that we could do it in two steps if we want. It's totally up to you. So I'm going to say angle 1 is congruent to angle 2. That's the definition of an angle bisector. And in the next line, I can also say 3 is congruent to 4. And that's also the definition of an angle bisector. Again, if you prefer to do that in one step, that's fine. Just cross out one of your lines because you will have an extra. So we're going to have congruent angles here. And we're going to have congruent angles here. Oops. Do we understand where those congruent angles came from? What about other people? I feel like Elle is getting this. What about other people? Are we seeing where the congruent angles came from? Okay. All right. All right, so we have our congruent angles. So I'll also label these. We got an angle here, we got an angle here. Now we need a side. We've run out of information from our given. We'll take a look at your picture. Is there something special happening in our picture? There is a shared side. What could we call this shared side? Like, take a look at its endpoints. What would we name it based off its endpoints? Yeah, CB. Again, take the two letters on either end of it. So that's CB. So we're going to be able to say that that is congruent to itself. Someone refresh my memory. We've done a few of these so far today. How do I talk about my shared side in my proof? What do I say? What do I write down? Very good. I said, what would I write as my statement, though? Yep, exactly. Segment CB is congruent to segment CB. And again, remember to get that name, just take a look at either end of it. Those are your two endpoints. And that is the reflexive property. Good. Now, take a look. We can now say that the two triangles are congruent. By what property? We have two sets of angles and a side. Which one do we think this is going to be here? Very good. Angle, side, angle. You had two sets of angles and a side, and the side connects the two angles. So angle, side, angle. And again, if you label it, you can clearly see it written in that order. And then we can say the two corresponding parts are congruent, because if these two triangles are congruent, then all their corresponding parts are congruent by CP/CTC. Any questions on that one? All right, last one. So here we are given that segment BA is congruent to segment CD, and that angle ABC is congruent to angle DCB. So that is given, and we're trying to prove our parts are congruent here. So we need to end our proof in CP/CTC. And in order to end our proof in CP/CTC, we have to first show the two triangles are congruent. Now this is a little tricky because can you guys tell what's happening with these two triangles here? Can you guys see it? What's happening with these two triangles? What are they doing? Well, they're overlapping, aren't they? Yeah, so if they're overlapping, I would take them and redraw them, or if you have highlighters, it can be nice to highlight them because then you can kind of clearly see where they are, right? And then, so I would redraw these for sure. So we have our first triangle here. This is, and it doesn't have to be perfect. This is A, B, C. That's the one I highlighted in blue. And then we have our other one here. This is DCB. That's the one I highlighted in pink. And then that just makes it a little bit easier to label. So we have that BA is congruent to CD. So BA is congruent to CD. So there's a set of congruent sides. And ABC is congruent to DCB. So we also have a set of congruent angles right here. So we already have a set of congruent sides and a set of congruent angles. We either need another set of sides or another set of angles. Let's finish putting in our freebies though. Again, now that we have it separated, it's a little bit easier to see what to call these. In order to say the two parts are congruent, you're going to have to say that triangle ABC is congruent to triangle DCB. And we'll figure out why in a second. So we already have a set of sides. We have a set of angles. We either need another set of sides or a set of angles. Now we looked at a picture really similar to this on our homework. We actually looked at two of them. What are you going to have when they overlap like this? Yeah, we're going to have a shared side. Can anyone see where the shared side is? I would take a look at that highlighted part. Do we see where those two colors are overlapping? Anybody? BC, yeah. We have our shared side right here. It's where it like kind of turned that darker blue color where the pink and the light blue overlapped. This is our shared side here. And if you take a look at them drawn separately, the blue triangle has a side BC, the pink triangle has a side BC, so that's our shared side. So we're going to say that segment BC is congruent to segment BC. That is the reflexive property. And now we can say our two triangles are congruent. So if we take a look, we were given a set of sides, we were given a set of angles, and now we have another set of sides. So which theorem do you guys think this is going to be? It is. Yeah. You got a excuse me. You got a side, an angle, and then another side. Side, angle, side. And then the parts would be congruent by CPC, TC.